Doubling and halving game, you need a pair of dice and a target sheet, which I would definitely have in a sleeve and use whiteboard markers. Okay? Take turns rolling the 2 dice, arrange them to make a 2-digit number, either double or halve the number to get as close as possible to the target number. Okay? Record doubled or halved numbers on the sheet. Complete 10 rounds, and the winner is the person who gets the closest to the target number the most times. And this is something that I would differentiate. This winning rule, I would differentiate, okay? And have players prove how close they were, or that they were closer than the other player. So, 6-sided dice is one way we can play, just like the picture. I roll. I make a 2-digit number, not by addition, just by place value. So I have a 5 and a 6. So I have either 56 or 65. And I have to either double it or halve it to get as close to that as possible. So if I was obviously teaching doubling and halving at this time in preparation for this game, they would know and have some models to do this. I would not be picking 65 because I know 50 is double 25. So 56 will get me closer if I have it. So if I cut 56 in half, that would be half of 50 plus half of 6. This is one way to write it. Maybe not my favorite way. How about I take my 56 and show that I know it's equal to 50 plus 6, and I can break that in half, which would be 25, and that in half, which would be 3, leaving the other piece empty, or show that it's there. Now this will get confusing when we get to multiplication. This kind of factor tree notation. So, even though it was easy, why don't we draw it as a whole thing cut in half, which would be 25 and 25, plus 6 could be cut in half as 3 and 3. Now we're talking folding paper and so forth. Okay, so 25 plus 3. Now it's your turn to roll. Oh, you rolled a 6 and a 6. Not a lot of options. So you rolled a 66, which is like 60 plus 6, place value partitioning. Whoops, going against my own practice. That would be 30 plus 30. 6 would be 3 plus 3. Now I know that. If I'm not knowing it and playing the game, which is what we want, make the number 10, 20, 30, 40, 50, 60, 66, and cut it in half. Well, here's one way that goes really well. No, that's not half. Take it and share it equally. So, what do we have? 10, 20, 30, 3. Now, 33 is larger than 28. On the way to 25, player 1 gets a point. Okay? Roll again. Player 1 gets a 5 and a 2. 5 and a 2 could be 52 or 25. That would have worked out either nicely or badly at the last one, because you actually have to double it, or halve it. Okay, now I need to get to 37. Well, let's unpack this a bit. If I took 52 and cut it in half, 52 is like 50 plus 2, so half would be 25 plus 1, which would be 26. If I used doubling, I would use 25. Therefore, 25 plus 25 is 50. Which one's closer to 37? I need a way to show it. I want to get the best answer. There's no rush. Draw a number line. Where's 37? There it is. Where's 26? Down here somewhere. Where's 50? Up here somewhere. Encourage people to find out how many it is to get down to there. Well, 7 would get me to 30, and then 4 more would get me to 26. That's 11. Off. 3 up would get me to 40, and then 10 more would get me to 50. That's 13. I want the 26. Closer. Now, of course, we could do the very same thing on our number lines. Drawing just what was drawn here. Okay? So if your students aren't adding and subtracting on open number lines, have them do it here on lines that actually have not only the reference, but even the numerals written. Okay? And away you go. Great little game. Making sure that they not only just guess, oh, I'm going to double, oh, I'm going to half it. Push them to have reason with their choice.